Hello, hello, hackers. Welcome back. This time we have completed the intro part, and we will get started on the end part or exit part, or what we shall call it. And I will create a new folder for that. Call it extro. That sounds very fancy. So there we go. Now there we go. So we have our file main.asm. Now I'm not gonna retype everything that I have available from before, so I'll steal some of it. We're gonna need probably this one. So we'll put the text on top, so that's fine. Let's just see that it works. Yeah, and we're good. Okay. Now, the first thing that we're gonna need is a character set. Now, I have two character sets that I've made in the past. This is a one by one character set. So it's basically looks like that. Got all the characters that we need. Or alternatively, I have the 1x2 character set. Yeah, it's basically 1x2, but have some letters which are wider than normal. But it's either it's full characters this time, so it's either one character wide or two characters wide, and it's always two characters tall. So with a 1x1 character font, it might be too much text on two. So I'm gonna start with the 1x2 font. I'll use that, and if that turns out to be too large or how it is, I can change it out later. The character set itself here, the quantity is 384, so it means that I cannot fit this into a straight character set, so I need to compress it. And I also need the tile set then, because basically what he will do is to recycle characters, and I'm gonna need a tile set to actually rebuild the character. So that's done by this button here, compress the data. And I can remove duplicate characters. That means this is the character, a 1x1 or 8x8 pixels. So I'll do that, and I see the quantity is reduced to 147, which is fine. So what I need then, I need the character set, which is here, and I need the tile set. So I'll export yeah, the character set. See if we can find it. 1x2 character set dot binary. And we will also export the tile set. And then that will be the 1x2 tile. Wow. Tile set. 1x2 tile set and 1x2 character set. So we should have them here. Yes. So that should be fine. We need to define where we want to have these things. So we'll keep it simple. We'll put it to 2000. To 800. That should be fine. So there we go. And then we need to import the files. I have an import here somewhere, yes. So import binary. There we go. And that one. There we go. And then we will make sure they end up in the right place. Yeah, that should be right. No, it is not. Invalid token. Yeah, of course. On x2. So let's swap those around. He doesn't like labels or constants that starts with a number, which is fine. So we can see then that the character set loads from 2000 to 2497, and the tile set is then from 2800. So that should be alright. Now, the next thing that we're gonna have to do is to take a look at or decide how we are going to do the up scroller. There's a couple of ways we can do it. We can do it straight, but again here, as I mentioned when we made the intro, you have to be careful where you pull graphics, or actually more precisely where and when you pull up the graphics. So this has to be done correctly in order to not make it glitch. And alternatively, you can also use double buffering. But basically, double buffering will make it very easy, because then you can put timing anywhere you want. Basically, with double buffering means that you draw to one screen while you show the other, and you just swap them around. Next frame, you show the one you drew to the last frame, and you're updating the other one. So you're never actually showing the screen that you are drawing to. And this is a technique that lets you avoid this type of bugs, and it also allows you to put the raster time anywhere you want, basically. So I think that is okay way to do it. That gives us a little bit of freedom. So I think we're actually gonna do that. So we're gonna do screen memory 1 and screen memory 2, and we're gonna basically put it to, let's see, the 2497. Let's put that to 25. Let's just see if we can be a little bit more economic with the memory here. So that means that we fit all of this, the tile set and the character set, before 2800, which means we can put screen 1 to 28 and screen 2 to 2C. That should work fine. That gives us our two output screen memories that we can alternate between. So that's made our memory footprint a little bit better. And depending on the amount of text that's gonna go in, it might be that this isn't the right place to put this text either, because it's going to be perhaps a bit long, and then if it goes, this will then obviously be running from 0800 and outwards. And in the end, you will depend on how much data or how much text you put in, you might crash into the character set. So we'll see how that goes. Then we'll relocate it. Maybe we'll just do it in an external file, so it's easier to update and just import it. So, but that's not a big deal. For now, we can keep it here. So that means we have a plan for how we want to do the double buffering, and we need to figure out the soft scrolling part, which is the D011, and D011, that is 53265. Now I must admit, probably 20 years ago I could remember this by heart, but I simply can't anymore. And for D011, the standard value, so let's just type this down here. (53265). The standard value is 1B, which then clear 1B, which is equal to 27, which is equal to 1 and B 1011. So this is bitmap mode, this is screen on, so if I remember correctly, and I believe it's the 3 last bits that control it. and that one controls the if the height of the screen is 24 or 25 characters, but we can play around with that. So let's just reset. And what did we say? 27. This shouldn't do anything, which is correct. Now, if I put this to 26, it scrolls upwards. 25 scrolls up. 24 up. 23, and there you see with 23 we now went to 24 lines instead of 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20, 21, 22, 23, 24. But the 25th line is still there, but it's hidden under this bottom line here. So we're going to need this in order to obscure the text that is scrolling in. We don't want it just to appear. We want to hide it under this line here. So 23 in decimal, that equals 17. So 17, shit, 23, which equals 1, and then it is 0, 1, 1, 1. So that means when we set D011 to 17, we will turn off that bit, which will enable 24 line mode, and then these three is actually pushing the screen down by 7 pixels. So if we were now to decrease this one with 1, it should soft scroll 1 pixel up, which it does. And 21, 20. So used to using this numerical keyboard. 19, 18, 17, and 16. And there you have it. Now it's been shifted up. There's 1 pixel left on top. And then we will actually move the graphic up. We will reset, push it down, and then we get our last pixel. If we put this to 15 now, this will go completely bananas. Because then we actually turn off the screen, and that's something that we don't want. So our values then will range from 17 to 16. Which will be 0, 0, 0, like that. So there we have it. That's the values that we need to do to soft scroll vertically. So that's fine. When we since we also have variable width characters here, we need a width table as we had in the other part. And I also want this to allow the text to be centered. Maybe I'll even do left and right alignment. I'll see. That's not critical, but maybe I'll do that as well. But at least as a minimum, I want the text to be centered. Now, what we'll do is, so we'll start with the screen pushed down and we will start to show screen memory 1. So here are the steps then. We will read a text line, center the text line, and print it to a buffer. So a buffer basically means memory that is not screen memory. So we will position it further down. And that basically is just 2 lines, which is 80 bytes. I'll put somewhere, just make a memory location for it. So when I read the text line, I'll convert it, read in from the tile map, and print that out after I center it onto this buffer. And then we'll clear the screen. We'll show screen 1, screen memory 1, and then we will copy the contents of the top line of the buffer onto the lower line of screen number 1. And then we will soft scroll it up, at which point when it reaches the upper position, this value, we will in the meantime have copied the top line and the 2 lines of the buffer onto screen 2. Then we'll swap over to screen 2, show that, and then that will give it the last 8 pixel scroll position. It will be reset, and the second line will be visible on screen number 2, and then we'll start to soft scroll that up. And then we will copy from one screen to the other for the rest, but for the buffer handling, that should be done like that. This might require a little bit fiddling to get it done, but basically that is the plan then. So first things first, we have the character set, we have the tile set. The first thing now is to make a width table and a character display routine, like we did in the last part, so that shouldn't take too long. Now I'm gonna cut the recording here and finish that table. You don't need to watch me click that in, but basically what I will be doing is just from charpad yeah, that was the wrong one. 1 by 2, there we go. So I'll just basically this is character 0, 1, 2, 3, etc. And then I'll just put a 1 here, and when we come to the M, that will be a 2, and then that will be a 2, that will be a 2, 2, 2, and 2. The rest are 1 characters wide, so it's not a very complicated table. So I'll be back once I've made the table. Okay, so the width table is made. It's a little bit simpler this time. The undefined characters I just put to 0, which are basically not doing anything. So that's that, and basically the first thing that we should do then is just to something like that. No, that's fine. Now we have actually done a little bit of calculation on this before. Can we reuse maybe some of these things? So this is the count line code that we used in our last part, and it's basically just to read the text, check if it's done, and then just add that to the serial page register 1. Now, to be fair, we will never need 16 bits in this case, because the biggest width of a character is 2 characters wide, but still it can maximum be 40 characters regardless. So actually we're just gonna use setp temp. That's good enough. Yeah, that's fine. And add with temp. And that needs to be 16-bit. The count loop is on top. So I'm thinking I'm going to put this ink here. Why? Because once we, because it has to be able to do several lines. So once we reach the FF character, I still want to increase the counter to go to the actual next line. So instead of resetting it. But maybe for the test case here, that is not such a good idea. So I'll keep it here for now, but later on I'll move that up here. So there we have it. We have hopefully managed to count the width of this let's just see what value we get. Well, if anybody knows how to get this monitor to pop up on the right screen, please let me know. So let's see, D08 E, so 0821, there we go. So he actually writes the byte 60, which sounds unreasonably high. "96, that cannot be correct." Ah, yes, of course. That makes perfect sense. There we go. So 11, which means 17 characters wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Beautiful. So the counter works fine. The next thing we'll divide that by 2. Then we have the offset to center it. So I think that's going to be it for this first episode. We have at least gotten started. We have a plan, and next episode we will continue on this display code so we can show this character set correctly. But until then, happy coding and take care, guys.